Live? All right. Thank you everybody for coming out. I know we kind of already talked about this earlier. My name is Drew with LAI. We got Joe Fisher here with RotorK Controls. We have Mark Martina here as well with ABB. Just going to give a little talk about some electric actuators and some ABB VFDs, variable frequency drives. In terms of the electric actuators, Joe brought, it looks like a butterfly valve with him today. Just know that the electric actuators are used in a lot more applications than just the butterfly valves, right? Plug valves, gate valves, sluice gate valves, probably even pinch valves, things of that nature. All sorts of different applications, and then on top of the electric actuators, they also do pneumatically actuated valves. I don't think he's going to talk too much about today.
No.
But, those are some other options as well. So.
Perfect. Yeah. All right. So thank you, Drew. So, yeah, as Drew had mentioned, I'm Joe Fisher with RotorK Controls. I've been on their inside sales team for the last 8.5 years until about 1.5 years ago when I started on the outside sales. So very familiar with what this looks like on paper. Still like getting my hands on everything, so love doing presentations like this. But been with RotorK a total of 10 years. So we're going to go over some just generic electric actuator information, so it's not going to be necessarily RotorK specific. Some of the features might be specific to RotorK, but for the most part it transfers over to the entire industry if you guys do have some of the competitors. What I want to go over here is I'm sure you've seen a wide variety of different technologies. I guess a good place to start is how many people are used to working on or seeing actuators out in the field. Is that something that's pretty common? Okay. So you can tell, I mean, over the years, realistically, the biggest thing that's changed over them is how do we interface with them? So larger the LCD or LED screen is, more likely the newer that the actuator is going to be. You can still do a lot of diagnostics on the old systems. It's just whether or not parts are available. But the technology internally hasn't really changed all that much, except for maybe a little bit more safety. Hand wheels aren't spinning when the motor's spinning, those types of things that we'll go over a little bit later. But here is just a basic example of what the front of almost every actuator is going to look like as long as it has a local control. You will see some that don't, that may be fed from a remote panel, or different companies that remote mount their head if you have a hard to reach location. We have the ability to duplicate that. We don't offset our heads, but we do duplicate it and mount it on a wall. But you should have some combination of an open close knob, which in our case is going to show the valve either flowing open or stopped. Usually doesn't say open or close because we don't necessarily know what direction you're going. And then a remote stop and local switch. So if you ever see on your PLC that you're not able to operate the valve, first thing to go out to is say, hey, is that knob in the remote switch? Is it actually communicating with our system? And then the LCD screen, depending on who you go with, it's going to have a multitude of different information. For ours, I like it because the screen that we have right now will show if you have a communication system or if you have a application that's going to run with a high level of torque. We can see that in real time as it's going through. But here, just a very basic overview. So a little cutaway. It's essentially your manual override. Your motor is on the back end. It's going to be feeding a worm wheel and a worm gear. That'll either be spinning 360 degrees or 90 degrees, depending on if it's a direct quarter turn drive. And then you have your drive bush, which is going to be your connection to the valve. So if you can see here on the actuator, a lot of the times when I was in inside sales, what I would get is people telling me, hey, we need to replace your RotorK valve. The actuator and the valve are considered separate items. LAI will sell them together. But if you are having a valve issue, I'll definitely go out there and I can take a look and help you out. But it might not be something that is an actuator-related issue. So just knowing that they're separate kind of helps expedite that process. And here in the base assembly, typically there's some sort of an F or FA pattern. So you should have a standardized mounting base and assembly that you'll be able to not necessarily have unique adaption setups, but it should be pretty straightforward every single time you're attaching it to that valve. If all of a sudden it's not fitting together, you could have something machined incorrectly. But as you're going through some sort of replacement process, just know that as you're measuring this, there's most likely documentation, drawings on what those bolt circles are, and we can help kind of figure out, hey, how are we going to mount this actuator to your existing valve? Here's a better exploded view. Some key features with actuators, the number one thing that we want to do is we want to keep water out of them. So for the life of actuators, as we started putting more electronics in there, the more moisture that we get in, the more problems you're going to have. So sealing conduit entries is a big one. I used to work for an electrician company, and whenever we had something that was going to be outside, making sure those whips, when they're coming down, you got a nice loop in them, something that's going to capture that moisture. Because if all of a sudden your seal-tight conduit entry fails, you're going to get moisture into the actuator, into the terminal bung. All those terminal points are going to start to corrode, and you're going to start to have a lot of problems. Everything else on the actuator is IP68 sealed. That's fairly standard with every actuator across the board now, just because everyone wants to keep water out for better longevity. But if all of a sudden you do start to see moisture creeping in, what we have inside of ours, all the electronics generate enough heat to burn off all the condensation. Some people will have internal heaters. If those heaters go out, you can start to see moisture build up, something to address right away. If you see any seeping out of the actuator in their seals, I don't know if the camera's going to get me here, but out of seals here, out of seals around the drive bush, if you have any sort of fluid leaking out of there, best thing to do is call that manufacturer right away. Start to get that taken care of. Because what's going to happen is sun's going to hit it, or heat's going to hit it as you're warming up the actuator. It's going to kind of push out that atmosphere, push out that oil, and then when it cools down, it's just going to suck moisture from the air right back in. So the sooner you get stuff like that addressed, doesn't happen too often, but if you do see it, it's a better thing to happen early than it is to not notice until all of a sudden everything's corroded. Here it's a little bit more of a modern design, so I don't know what type of actuators you guys are more familiar with, but a lot of the times on some more mechanical style features, you'll have a slide potentiometer or you'll have a rotary potentiometer. We've replaced that with the absolute encoder. Most manufacturers have now as well. It's very few moving parts, very few wear parts. On a standard potentiometer, you have almost like a brake pad on your car. It's going to be a wiper. It's going to be elongating and shortening that distance so that it can tell where the actuator is in its travel. That'll wear away. That'll wear away, and eventually that's just not going to be able to tell you where your actuator is. You're going to have to reset your limits. It's a big hassle. So everybody's moving to more of this style with a Hall effect feature. So it's a bunch of rotary gears with magnets. It's going to tell the actuator exactly where it is. You're not going to lose your memory if all of a sudden the actuator loses power. And if it rotates when the power is off, it'll hold that position. So as soon as your PLC, as soon as your actuator gets power again, it'll be able to tell it exactly where it's at. So it just kind of helps, safety proof everything. If somebody's not communicating and they go and open and close the valve, you're not going to have a PLC that thinks it's open when it's closed and then try and send it a signal that it shouldn't be receiving. So, terminal bung in there, that's where all of our wire connections are made. So it's in the back side of our actuator here with all of our conduit entries. This is the only spot that you should have to open. Whenever you're setting up any sort of actuator, you shouldn't have to open up the front end. Again, that introduces moisture. We want to try and reduce that as much as possible. So if you are maintaining and setting up an actuator and you do have to open that up for some reason, just make sure it's covered, make sure it's not raining out or you're not in a really damp location. But the terminal bung is double sealed. So I've seen it before where somebody did not seal the conduit entries correctly and the electrical was not part of the scope, so it did not get replaced, and it was just a rain gauge and just filling up that actuator. So all we had to do was replace the terminal bung, pull that out, pull the O-ring out, put a new one in, and they were still good to go. The center column was fine, the electronics were fine. But just noticing that right away, again, is the biggest step. For the manual override, well, we have this cutaway here. So you can see the handle on the top. When you pull that down, that should disengage the motor, the electric drive motor, on, again, every make and model of actuator that comes out now. And that'll allow you to start spinning that hand wheel. Hand wheel should only be around 80 pounds of force, especially in the wastewater world. AWA requires that typically. Some specs will have it as 40 pounds, but it should not be where you're cranking on the thing. So if you are doing that, that's a good indication that, hey, maybe there's an issue with the valve, maybe there's an issue with the internals of the actuator, something's causing too much friction. So, and then when the motor kicks back on, we'll show you next time on this one, but you'll hear it click over. So, sorry. You'll hear it click, and all of a sudden you'll see that, you'll feel that dog ear just kind of engage again, and then the hand wheel will stop spinning, and your motor is taken over. So that's just a breakdown there. You can kind of see the declutch mechanism and the spring that'll bring it back as soon as the motor engages. So you don't have to worry about re-engaging a hand wheel in there. The motor will do that for you. So I know that's kind of more IQ3 related, but just a safety feature in order to meet NEMA 6P, and that's typically the personal protection and something that's very common. There's a good example of the double sealing in the terminal compartment, because again, that should be the only place that you guys are opening the actuator up on. The electrician is landing all the wires. It's not always the greatest environment, so we wanted to make sure that that was separate from the body of the actuator. So if you are getting any sort of water bypass, any sort of water into the center of that actuator, you probably have some O-rings that are failing and need to be addressed right away. So in the control knobs, because that might be something that a lot of people point to as like, hey, you might be watertight everywhere else, but how are you controlling this if you got holes going through your actuator face? So what a lot of people have moved to in the industry is more of a Hall effect sensor. So we don't physically drill holes in the front of the actuator at all anymore. Water can't get in if it's blowing sideways. It is sealed off from the environment just through the casting. So it allows for that IP68 rating that I think almost everybody's spec has nowadays. And you can kind of see the little locking mechanism. I like that there. If you don't want people tampering with it, actuators should have ability for you to lock out their manual controls. If it's in stop, you're not going to be able to do anything with it. If it's in remote, you won't be able to operate it locally. And then if it's in local and you lock it out because you're doing some work on it and you don't want the PLC to tell it that it should move, you can lock it out into local to make sure nobody messes with it. Yeah, just a padlock or anything you can stick in there to stop it from moving. So actuators will come in a bunch of sizes. So if you see something that's direct quarter turn, or if you have a certain size on a valve, but now you got a larger valve, you might be getting something a little bit bigger. Just to kind of, a lot of people will see our literature and assume that you just put a bigger motor in or something like that. But you have different base sizes that you have to hit in order to meet certain torques. So every actuator, as you go up in torque, the size of the actuator will most likely go up, or the size of a gearbox that you couple with it will go up. And then the top hats and the cover tubes will cover as well, because those are also very important for keeping water out. So enclosures, every actuator manufacturer should be able to do watertight enclosures and hazardous area. So if you do have something that's class 1 div 1, if there's any sort of combustible gases that are present, we do have castings that have flame paths and are certified by FM and CSA. Certain builds, sometimes you get one regulatory body over the other, but either way, most of the time it just means class 1 div 1, and it won't set the entire environment on fire if you do have some sort of electrical event inside your actuator. So knowing what enclosure you have is sometimes required. If you are working on the actuator and all of a sudden it is explosion proof, a lot of the times factories like to take care of that themselves. Just to make sure that those flame paths are not damaged, that the certification doesn't go away, and that you guys don't have any issues. So if you do have any explosion-proof environments and actuators in those areas, if they're malfunctioning, call myself, call Drew and LAI. We'd love to come take a look and make sure that's not something that the factory has to take care of, just so you're still certified and that we don't have any issues further on down the road. With the local interface, there's a little bit more information you're able to get out of that nowadays than you could with some of the simpler actuators like our old A-range. Those are all mechanical features. Not a whole lot of data you're able to get. Nowadays, you're able to get a lot. We have torque curves, we have number of starts, we have the amount of current draw that it's taking. So you can do a lot of diagnostics through the actuator. That's not necessarily actuator related, but is more process and valve related. So if all of a sudden you're worried about grid on a stem, or you're seeing a lot of current draw going out to this actuator, with ours, I'm not too sure about competitors, but with ours I know the menu itself can show a torque curve as it's operating. It also has a data logger inside of it that measures 3,000 events, and it will save all the higher torques than what it's used to. So you'll be able to see an overlay of, hey, this is what it normally does, this is what it's doing now. Maybe come take a look and see why it's acting up as much. Again, it could be something with the actuator, could be something with the valve, could be something with an obstruction's going through your pipe. But at least it gives you that heads up. And then there's our Local interface again, so you can see all the electronics are hidden behind it. The electronics are where you're going to have all of your control cards. So if you have a, just a main control card that's handling the brains of the actuator, that should be inside of that HMI. If you have any sort of Modbus card or Profibus card, something like that, that's also going to be located back there. Most of the time, you don't have to open that at all. If you are opening it, usually means something's going on, and we'd appreciate a call to help you guys out. I like to include this just because before we start getting into the valves, so we have a setting tool in order to control ours. Most of the time, you're able to set up the actuators through the local controls. We also offer that option as well. I like the setting tools a little bit better just because you're able to keep your hands in your pockets, keep them warm as you're going through a lot of settings. They are Bluetooth enabled. Specs nowadays typically call for that. Whenever you do see something where it calls for Bluetooth, for ours, you do have to infrared, get up there and handshake with it first. So there is that security setting, because I know a lot of people are worried about that. People coming in, they can't just mess with their phones, mess with Bluetooth, and start operating your valves. It's going to have some sort of feature where you have to be within line of sight of that actuator before you can start operating it with the setting tool or with whatever application you got going on. I'm going to skip past a couple of these because these are RotorK specific, but there's the internals of the absolute encoder that I was talking about previously. So with that, you can see it's very few moving parts. If you're starting to lose limits on your valve or on your actuator, if all of a sudden it's not feeding back or your flow rate isn't what you're expecting for where the position is of the valve, typically it is the encoder. That's what's telling the actuator where it's located. So first thing to start, replacing. These usually don't lose limits as much as they used to. So I know that was a big thing. Hey, it's not seating properly. It's probably limit loss in the gear train. They don't have a gear train anymore for limits. Now they just have the encoders. So if you are starting to lose limits, that's the first thing that I'd recommend replacing. But again, it doesn't happen that often just because it's a very simple piece of equipment. Only 4 or 5 moving parts, and they're not very load bearing, so you're not going to wear out those plastic gears very often. Skip past that. So this is a direct quarter turn actuator that I brought today. They're just lighter, easier for me to carry. Not a very strong person. But we do sell primarily a lot of multi-turn actuators. With that, you'll see them on larger gate valves. I've seen a lot of applications where they don't have cover tubes. If you have any stems out there that don't have cover tubes, I highly recommend putting them over those gates. One, it's going to save corrosion on the gate, something that we can't really, as the actuator manufacturer, control, but it'll also stop water in Illinois, Wisconsin, Michigan, my territory. It'll stop water from getting down to your gear train into your center column, freezing, expanding, and starting to break stuff. So if you don't have cover tubes on your rising stem applications, again, that's something that we would highly recommend. If you have a RotorK out there and it doesn't have one, I can get you the adapter and we can definitely get it taken care of. With these, you can kind of see up top, doesn't really look exactly like there's an actuator on there, but there is a spur gearbox. So we do offer, and everybody offers, multi-turn, quarter-turn gearboxes to give a little bit more oomph on larger applications. So if you are looking through any sort of literature and you see, hey, I want to get a RotorK onto this valve, or I want to get any sort of actuator onto this valve, oh, the torques don't go up high enough for what I need. We're able to use auxiliary gearboxes in order to meet that torque, so always reach out. I'm sure we can find something. And then here's more for the direct quarter turn. So most common you're going to see are butterfly valves and plug valves. Both with, and actually I should probably go back, with the gate valves and with the quarter turns. When you are setting these up, which we can go over this a little bit later as far as how to set these up, you're going to have different torque percentages for your seats versus your opens. Ours is all done electronically. I know other companies you can set those torque ratings manually. But if you're driving a valve into a seat, you want to have less force driving into the seat than you do have pulling it out, just in case you have frost or freezing, you have any sort of obstructions that you might have wedged into that soft seat. You want to be able to have at least, I always set it for 15%. So for example, on a larger gate like that, if it requires, we'll ship them out at 40% of rated torque just to make sure nobody breaks anything right away. So that's another thing if you're setting up a RotorK actuator, and I apologize for jumping around here, just clicked in my brain. If you're setting up an actuator and all of a sudden it's not moving the valve, it's probably because the torque's still at 40%. Go into those settings, boost it up until it starts moving. But with it, you don't want to have the torque seating the valve, pushing it in there at the same percentage as you do opening it. So usually a 15% difference is what I recommend. So if you have it at 50% to seat it, maybe shoot it up to 65% to pull it out, and that should give you that extra oomph to get over that seat. So same thing with the quarter turn type valves and the plug valves. You can see there it's got a soft seat. It's very common in butterfly valves. So as that friction is hitting that disc, you have the most torque that you need in order to push that out. So if you are setting something up for a butterfly valve and you still see flow going through, it's probably because it's not boosted up enough in order to overcome that friction into that seat. And then if you're stalling out as you're opening it, it's probably because it's at that same torque level and you just forced it into that soft seat. You want to boost that torque up so that it can come back out. Only very RotorK specific thing I'm going to put up here. We do have a new application that I use sometimes in order to duplicate what the setting tool does, but what's helped me out being a newer area salesperson is we have recommended valve seating. So what I was just talking about the percentages, about what the valve typically does, how you want to set it up. You can go through, we do have a section in our application, you can choose common valves that won't have really unique valves like triple offset butterflies, but we'll have more standard valve applications showing you, hey, this is how we typically set it up, these are standard run times, these are the torques that, the torque percentage differences that we'd recommend for the opening and closing. These ones are typically, for control type applications, these are open close. It gives you a lot of good information if you're staring at a valve and you're not too familiar with it. So that's the end of the slide that I got there. Here, just going over really quickly. So, and again, if anybody wants to come up and play with this afterwards, I promise you can't break it more than I have. So it'll be fine. But setting tool, if you have one of these laying around, put it somewhere safe. They're very, not difficult to come by, but they're easy to lose. So I want to make sure that, if you do accidentally misplace one, we can always get you a replacement, but they are fairly valuable. In here, we have our first thing that we're going to notice is a little battery compartment. So you might see something on an actuator listed like battery low or no battery. There are internal battery backup systems that will close an actuator on loss of power. That is not what it's referring to 99% of the time. This battery, what it will do is it'll send a signal back to your PLC if you lost power to the actuator and somebody moves it and you have discrete control or something along those lines where it's telling the PLC, hey, I'm open or I'm closed, that battery will still send that signal for up to 30 days if you are using it consistently during the day. So it's just a way of telling your system that somebody's messing with it. Maybe they should be, maybe they shouldn't be, but even without power to the actuator, you're able to get that information. That, again, that should be common on a lot of different actuator manufacturers. But for mine, you can see a nice big triangle on there that shows an indication that that battery's dead. Actuator will still work just fine. If you have RotorKs out in the field and you see that error, it's not life or death. Something that you could go to the store, get a 9-volt battery, throw it in there, and get it to clear out. But it is annoying seeing that little triangle up there, so I always like to point that out right away because sometimes people don't know where that's located. But here, what I'm going to do real quick is just unplug this and then take this terminal compartment off so you can kind of see the terminal bung. But again, only portion that you should be operating on or should be working on is back where the conduit entries go. And then checking to see if they're tight. That's one of the first things that I always do whenever I walk up in the field, just making sure that they're not hand loose. If they're hand loose, that means water's getting in there. Even if it's looped, it might be allowing it to bypass. So if you have it in any sort of outdoor locations and these conduits are hand movable, get a wrench out there and tighten them up right away. But yeah, other than that, is there any other questions or anything like that on the actuators? Do you guys have anything specific at your locations that you're going through or anything along those lines?
Are there certain brands of valves you prefer to work with?
We'll work with anybody. So around here, I know we like RotorK. They have a lot. That's actually the last 3 years of me quoting. I was in charge of quoting RotorK valves, so they're the ones that I'm more familiar with. But any valve manufacturer we'll work with. They'll reach out to us. We'll put our actuators on anything that needs to turn. So. Correct. Yeah, and that is something with valves. They all have their own proprietary information. They have their own proprietary torques. Typically, they don't give it to us. So if you are doing a retrofit, we like to come out on site, take a look at your old application, try and get as much information as we can.
Some of the issues we've got Desert valve with limit torque actuators.
Mhm.
Desert didn't want to give their torque ratings
Yep.
during startup, so we had to kind of work through some of that.
Yes, and that's very common. And again, if ever those are getting replaced, whenever we go out there, we won't have those torque ratings either. So knowing that ahead of time allows us to kind of get access to the site, get as much information as we can on the old actuator versus the new actuator. But yeah, for the most part, they keep that pretty quiet because that's how they make their difference.
Real quick on that, so LAI, we are the Desert rep. They will give us some of that information sometimes, so we will work with them on it, if there's some issues, feel free to reach out to us.
Yeah. And so the last thing I'm going to show you here, I'm actually going to go grab an Allen tool right now and make sure that that's unplugged so I don't electrocute myself. Not that that's not fun with 110. All right. So all specs, well, most AWA specs nowadays will require these bolts here, just as a heads up. They will require these to be captive. So you shouldn't be losing the bolts out of here when you are opening it up, and that's a good indication that this is something that you should be inside of. These bolts here will fall right out if you do take the head off because they're not supposed to be removed during startup. So just quick little heads up there. But as we're popping this off, typically what I like to do if I'm working on these is I'll keep one bolt a little bit looser so that it can just slide right down so I'm not losing the cap. And I think I was in a UV channel yesterday and I had dropped one of the bolts. Luckily the wiring harness caught it, but it is very common to do, especially as it's cold. So if you do lose the bolts, contact myself or Drew. We can always get you more hardware. So you can see here, these bolts won't pull out. That one will, because this one right here, I had to replace. But inside the actuator, right now, what we have is we have our Ethernet IP card, so I apologize for all of the mess inside of there. But you should have clearly marked, indicated lines as to where your power goes and to where your communication goes. If you don't see a wiring diagram physically inside of the head, give us a call. We would like to get that out to you right away because it's very difficult to wire these up without that wiring diagram. These pins are not necessarily always going to be to the same thing either. So if you're setting up one application, that should be pretty common if it's on the same order. But if all of a sudden you go out and you're setting up another application on an actuator, it could be that these terminals mean something different. So just always reference that wiring diagram whenever you're going out and working on the electrical side of the actuators, if that is something that you guys do. And then one other thing on here that I did, in order to make sure I was ready for a little bit of a swap, I took the base off of this actuator. When I put it back on, I was a little bit hasty, and I pinched an O-ring. And now all of a sudden, Drew was in town for training, and my actuator was leaking all over the floor. So in the cold, it won't leak as much. As it starts to heat up, you'll start to see it seep out. If you do pinch an O-ring, call us up. We got soft good kits. Everybody has soft good kits. But if you are doing just general work on the base of the actuator, that's something to maybe also order from whatever manufacturer you go with, is replacement O-rings. If you can't get a replacement O-ring, taking a little bit of silicone every time you open that back up, beating it over the O-ring is going to help keep that longevity, stop it from drying out, and stop you from being able to pinch it as easy as I found out the hard way. But it's just automatic transmission fluid that's in here. It's not grease anymore. If you do see grease in an actuator, you might see it in the gear casings, but if you see grease in an actuator, just be aware that that has to be changed at an interval, otherwise you're going to start heating it up. You're going to start tunneling it away, and it's not going to be on the gears anymore. With the fluid that we have in here, you don't ever have to do an oil change on our actuators. So if you are doing that, that's great. It's unnecessary though, unless all of a sudden you see it leaking out. Any maintenance questions on the actuators or anything along those lines? Yeah. So yeah, if you guys are having actuators that are acting up and you want, Drew and myself or Mike to come out there and take a look, see what we would recommend. Usually we just need access to the stem we want to find out how big that stem is. That stem can tell us a lot of information as to how much torque the application might take, because valve manufacturers are not going to put a larger stem where it's unnecessary. That's more money. So it is going to be based on how much input force that stem can take. But then we also want to take a look at the mounting flange as well. So if the actuator is still mounted to it, that's perfect. We can usually do some measurements that way. But that mounting flange, again, is all ISO rated. It's all rated for certain levels of torques. So the size of that will correlate with how much torque the actuator is putting into the valve. So that also gives us a good indication. So if you are, all of a sudden you have to adapt an actuator, move it away from a heat source or something like that, just make sure that flange size is the same. If you start going smaller on the flange sizes, you could have issues where you're going to twist metal, or it won't be rated for the amount of torque, and it'll start to loosen up. That is a good point. We show up a lot of the times, and depending on who we're there to see, it might be somebody who's more mechanical. It might be somebody who's more on the valve side or the process side. But if we have an actuator that's hooked up to your PLC or to your SCADA system, knowing what system you guys are using is a big step. Typically, it's something that can be figured out without us having to be in the field. But knowing that it's a control card that we can replicate, that's also a big thing. Your system has to communicate with the actuator. For the most part, we can do almost every control card that's out there. I know some people have proprietary ones, so we just want to make sure we know that right away. But if there are control issues with an actuator, the actuator is extremely dumb. It's going to do whatever it's told. So if you are having issues with it communicating back to your PLC, that could be a good indication that a signal's not getting there, not getting converted, and then not getting transferred back. So it might be something with the actuator, but a lot of the times you're chasing ghosts inside the actuator, and it's something that maybe a fuse blew in the PLC in the box in the communication center, or some setting got turned different. So just like a car, go cheapest to most expensive. Checking software, checking wire connections, making sure nothing's loose. That's going to be easier than calling myself and Drew out there and us pulling an actuator off, sending it back to the factory, going through all the diagnostics, you guys having to go out there, operate by hand. That's not fun. So yeah, double checking whenever you have any sort of issues. The easier processes and the cheaper processes is always going to be a good way to start.
You might touch on this in your presentation, but we have an actuator, it's not rotor.
Mm-hmm.
When we set it to like 30% open, it'll only go to either 28 or 32. Like it will never stop at 30. But it's done that since the beginning.
So it could be how you're controlling it. If you do have something is it just an open-close setting where it's set at 30%? Or do you think it's like a 4 to 20 milliamp signal that's sending it?
So it's pulling through SCADA. So
Okay.
it's PLC that's telling it. There's a set point, you can plug in 30%.
So for ours is accurate to 1%. Some actuators are a little less, but also you do have settings inside those actuators. So if you need it to be a little bit tighter, whenever you do have, the most common control type that I see is 4 to 20 milliamp control and feedback. So we call that full-o-matic. Not too sure why, it's really confusing. But whenever we're going through and setting that up, there's two settings. There's hysteresis and deadband. Most likely that deadband's a little bit loose. It probably has that 4% swing in there. So it's looking for a set point, but as soon as it gets within that deadband range, it's going to try and stop. That allows for overrun, and then if you do have it really, really tight, what might end up happening is you overrun that 30% to 29. It tries to go back to 30%. It goes to 31. Then it keeps going back, and it's called hunting. And so that's most likely why they have it set at that level. It's up to your application. If you need it to be that accurate, then it's probably something where you want to look for a true modulating actuator instead of maybe a 60 start per hour open close. Because I guess one good thing to touch on, so thank you for bringing that up, is on open close specific actuators, you do have a hammer blow effect. That hammer blow effect is just slopping the gear train. So the motor can start spin up that gear train and hit that valve with a little bit of force to start to pop it open. One like this that's a modulating actuator, we don't have that. So you don't have to overcome the slop in the gear train in order to find that set percentage you want to be at. It's a very low inertia motor. It will stop within 1% as long as you have that setting correct. So there's a couple different things we could look at for that, though. You could.
But the deadband setting you're talking about is within the actuator.
Correct. Yep. Yeah, within the actuator, it might, depending on your control system, it might be something you can fix at your PLC at that level. But for ours, I know you would need to go into the actuator if it's 4 to 20 milliamp. If you got a control card like PAC-SCAN or Ethernet IP, then yeah, then you can do that over your either embedded web page or your control panel. But yeah, situations like that, that is where, you know, going through the manual, going through the settings, making sure it's what they recommend. But it might also be that that process doesn't have to be as accurate as that 1%. You know, maybe a little bit of slop is okay, depending on what type of media is going through there. And if you're trying to hit that, you might be chasing a percentage point that you don't need to chase. So.
Real quick, I think Joe brought up a good plan on that. You know, the right type of actuator for the right application. Actuator is not really, you know, lock stops and all, it's always kind of tightly binding. You know, you do want to go with modulating actuator for certain applications that are closed. And have like 16 stops per minute. When you start to overcome those amount of stops in an hour, then you like start to hit more.
Yeah, so it has to do with the motor and with the contactors. So that, thank you, because that's good. Anybody who's familiar with their kids messing with their thermostat, if all of a sudden they turn the heat on or the AC on and off and on and off, on the AC you got a contactor, a mechanical one. You don't want to have too many starts because that's going to overheat that application. So a lot of people, if you have a ring, or not ring, a Nest or whatever it might be, you'll see that it has a timer where it won't do another cycle, it won't turn it on again. Similar thing with open-close style actuators. It's a mechanical contactor. That's going to generate heat. That's going to be a wear item. So you want to limit the amount of times that you're going to be starting it. Most of the time, those are used for applications where you're just either fully opening the valve or fully closing it, or you know it might be somewhere intermediate, but you have two set points that you're going to, and it's not operating all that much. It's usually an application that's either always open or always closed. For the modulating, it's a solid state starter. You don't have those heat issues. We have ones that are rated for 1,200 starts per hour or 1,800 starts per hour. Those are typically AWA levels that they want you to be at. But it's all about keeping heat out of the internals of the actuator and keeping that wear item down. So they are, you know, they're going to be a little bit more expensive because it's a little bit better technology. But if you do have an application that's true modulating, just make sure you're getting a modulating actuator for that. Otherwise, you're going to have a lot of errors saying, hey, you're starting and stopping too much. For a standard open close, you got different S ratings for internal motors. Standard open close is going to be S2. That means for every 1 minute of operation you have, you need 4 minutes of cooldown. For S4, like a modulating, it's a 1-to-1. So if you operate it, you know, constantly for a whole hour, up to those 1,200 starts, it might need another hour to cool down. But typically it's, you know, hey, I've moved for a second, now I'm waiting a second, and that's how you get that cooldown feature out of that actuator. So when you do see an application that requires really precision, I guess, set points that you need to hit in order to make sure you're hitting the right gallons or million gallons per day or whatever it might be, just make sure you're talking to your manufacturer about modulating versus open close. Yeah? Yeah. Sorry. Did this for a while and it sometimes gets all bundled up in here. So. Yeah, otherwise, if you do have any questions later on that you think of, I can put my card up here. Otherwise, reaching out to Drew, we can always get those answered. I'm always happy to talk anything actuators. So, thank you.
Well, actually, it has to be, it's kind of a mess.
I'll let you.
It's got to be so that the mic is like right under here, because it's real dimensional.
Got it. And that's more for the online, right? Is good. Okay, cool.
And then you know the flag, right?
If Drew needs to talk, I'll go stand by him. He already did all his talking at the beginning, so we're good. Yeah, and I know the flags. Stay within the flags. Yeah, I'll let you tell me when. What are you trying to do? Oh. So I just got to stay frozen in this spot. Just stay here.
Basically, you can move from flag to flag.
From flag to flag, right? All right.
Okay, we're good.
Yeah, that'll be good. So, all right. This is the second part of this. I said we're going to cover. It's basically all based with variable frequency drives. Obviously, that's what we sell and promote. So that's what it's going to be based on. What we're going to be covering are some of the features that are in the drive, but also some basics on the drives themselves, why you have them, what they do, what they're doing for you in the application and all. And then we're not going to go too deep on things, but kind of cover some of the topics. We'll kind of go through this as we hit up on it. My name's Mark, been around with ABB for a year, been around the industry for a long time, indicated by the hair and loss of hair and stuff that goes around, so I've been around a bit. If you have questions, feel free to ask, but we'll be around at the end, to as you well with this. So what we wanted to cover with this, in your application, there's a lot of things that impact your ability to keep your systems operated, right? They could be electrical based, so we're going to cover some things as to how the drive can be impacted by or can help, with some electrical situation stuff that you might run into. But you got your traditional, things like cavitation, water hammer. Do we all have aging infrastructure, systems involved? So talk a little bit about how drive can help, what they can do to help with that. Some of the installation practice, how your environment could be impactful. And I'll hit up on the process and control. We'll kind of talk about that a bit right at the beginning, because that's kind of like why we're using the drives, to begin with. What I'm going to do is tie this back into what we kind of call our water circle, but it's what are the features in the drive or that should be in a drive that actually are helping you keeping your system operational or make it easy to do your setup and different things. And these are the things I said that they may be in there and they're in that drive. You just don't know you have them. It's just a matter of turning something on, and then you have some capability that you didn't even know was there at the beginning. So when we talk about on the process efficiency, I'll go right to this one. It's like, in general, we're using the drives because we're looking for better process control, right? We're looking to try to meet some type of a demand. You got increased flow, decreased flow, increased pressure, decreased pressure, right? That's why you're putting a variable frequency drive typically in the system, because it's going to give you really close control as to what you're trying to operate and how you're trying to control with that. There's a benefit that comes with that, though, a lot of times, and that goes along with soft starting capability. So when you have things like water hammer, Drew, you mentioned the water hammer, we'll talk about that, but that soft start capability is a natural inherent with the variable frequency drive that limits that water hammer, situation that can happen with that. But you also get the energy savings capability, and that's because of the way the drive operates. It's going to provide energy savings, when you put it into an application. Oh, you can't see the gray on that, so this slide does means nothing. Basically what it would show you here is that with typical control, you put a mechanical device in, such as a valve, and you want to take, you're going to change your flow. There's really no energy savings that comes along with that. We put a drive in, the drive's actually able to kind of match the flow, and there are actually energy savings that will come about. I'll show some slides, and that's supposed to be red and gray. The gray really didn't kind of pop up there. So think of gray lines being higher than those red lines that are on there. So to understand where that energy savings come from, you got to kind of look at what type of load types they have. You basically have two types of loads. We don't constant torque and variable torque loads. You guys heard those terms before at all? When we say constant torque, variable torque. So a constant torque load, what it does for its full speed range, you're going to need the same amount of torque, the same amount of oomph, for that load. So think of it as like a conveyor. A conveyor just needs a constant kind of torque that's going to go along with that. When we look at it from the amount of energy that it needs, the horsepower that it needs, or the power that you're going to need to draw to run it, is going to be directly proportional to speed. So if you're at 100%, you need 100% of the power requirement. If you're at 80%, you only need 80% of the power. So there is some savings that comes, but it's not as pronounced as the savings that we get when we put drive, say, onto what we call a variable torque load. So a centrifugal pump is an example of variable torque type of a load. So shown, see if I can get this thing to work right. And probably not. Probably operator error, but okay, so basically the torque required varies by the square of the speed. So that's that upper blue line. So that's going to be how much torque. But when you go from a power standpoint, the power that's needed varies by the cube of the speed. So if let's say I need only 80%, say in my flow, that means I'm going to need 80% of speed, but I only need 50% of the power. So rather than drop it only by 20%, I drop my power requirement down to 50%. So that's where I end up with a significant amount of energy savings when I go to put a drive into an application. The way the drive does that, and this is kind of where I don't get too hung up on this, Drew. I know you don't want to see too much on this, but the way a drive operates, I got my incoming power, three-phase, your normal power coming in. On the front end of the drive, this is what we call 6-pulse drive. It might be a term you hear. It means I have 6 devices on the front end of that. I switch those devices. I convert AC power to DC. So sometimes on a drive, they'll talk about the DC bus. So if you ever have you might see a fault on the drive sometimes that says DC bus fault. That's what the DC bus is. On the back end, we have what are called IGBTs. We convert that DC, we convert it back to AC. And we're actually doing it in a pulse method. And what it allows us now to is control voltage and frequency that goes out to that motor. So now I can actually change the speed that I'm going to be able to run that motor at. And that's what's going to get me that ability to control and get the energy savings. So if I look at this is just showing you, I got to get this thing to work on here. It worked for a little bit. Trying to get the pointer to work. I don't want to do that. All right, I'll try to point it with my finger. So the dark blue line there, curving up, that's just your system curve. Your system curve, when you're looking at it, is just made up of all the kind of mechanical devices, your piping, everything you have in the system, right? So that's kind of naturally there from your system. You're trying to meet flow, pressure requirements. You're going to overlay that with your pump curve. So the line's kind of running down this way. Those are pump curves. So the top one is your pump curve, and you're going to pick that based upon how much flow, how much pressure I need, and then that point where they intersect is really what we call your natural operating point. That natural operating point is also the most efficient point for the operation of that pump. Now that's great if all you're going to ever do is run at 100%, right? Drew, what did you say you typically see on turndowns? About 50% a lot of times is low, right? So that means that, okay, my flow isn't always 100%, right? So what we're showing here, I could put a valve in there, and then what it does, it changes that system curve, and you think of that curve then moving back on that top black line. So what it's doing is it's just changing the system curve. And so I move away from its natural operating point, the efficiency go down, and it doesn't give me a lot of efficient operation or power, actual savings. The drive, you see the dash lines, those are if I'm lowering the speed. So the bottom dash line there, that's representing what I talked about as the 80%. So this is my normal flow, let's say 750. I go down to 600, so that's about 80% of it. But the power that you need then is only 50%. And so the drive basically is just moving down the system curve, and it stays really, really close to the natural operating point. So it's very efficient, you know, from that operation. So that's why a lot of times when you're looking at somebody saying, man, I don't have the money to put a drive in, sometimes you got to look at the next step is, yeah, but what am I going to save in terms of energy? Because if I can save on energy, I can a lot of times cost justify putting a drive in. And some utilities actually give you kickbacks, you know, to put a drive, you know, into the system with that. ComEd, different ones will have the different ones, different levels. A lot of times it's tied to a horsepower rating, and they do it based on the horsepower and putting that in with that. So if you ever need to do that and evaluate it, just reach out. You can reach out to Drew. Drew can reach out to me. We have a program, and we can do some calculations. It's just based upon how am I running my pump, how much time is it at various speeds, and that way we can take a look and see at what kind of energy. If you're always running 100%, there's not a lot of saving, right? Or 90%, there's not a ton. But if you're going down to 50 or you're at 70, you're spending a lot of time in that area, you can get a lot of savings out of it rather than running across the line. Yep.
Just something when you are looking at retrofitting application,
Well, we'll talk about that. Yep. That's a good one. We'll talk on that because a lot of times you're looking at retrofits and the motor type is important, you know, when we do that. So we'll hit up on that. One feature we do have in the drive, and so I'm going to keep going back to the circle, is a sleep boost functionality. So if you're at a point where, you know, your flow's just up, down, but it's really just, it's sitting always, you know, on a low, and it's just kind of cycling to go on for that. We have what we call sleep boost. It allows the drive just to say, go to sleep. You know, you can boost it up real quick, kind of get your, you know, get flow or pressure up, you know, and then you let it go to sleep. And it just keeps the drive from going through those the pump from going through the cycling modes. I think Joe's talking about the on, off, you know, how bad that is. It just lets it kind of go to sleep. And then when it's really needed, that's when it comes back. So that's a functionality that's built into the drive itself. Another one then I want to talk about is the power side of things, a little about the inequalities, or not inequalities, but instabilities that you can run into. One of the couple we ran into from the voltage is the voltage source being like, say, low voltage or imbalance in voltage. Those are real typical. Another is a term called harmonics. Have you guys heard that term ever? Is that any show of hands for harmonics? I see a couple. You've seen it. Drew kind of brought the harmonics up with that. So I'll talk about how they impact and stuff with those. So over here, that on the far right is that same 6-pulse drive that I was talking about. I convert that from AC to DC. When I convert from AC to DC, there's actually harmonics are basically generated, and they show up back into the line side of your system. And what they're doing is they're additive. And this happens with any nonlinear type conversion you have. So any power supply that you have, your computers, everything, they contribute harmonics. I do the drives because I sell drives, so I always like to talk about them because we work to mitigate that or not even produce them. But the problem with the harmonics are they can cause you on your incoming supply, like your transformers and stuff, you have to maybe upsize them, or you have to pick the right types of transformers actually to handle those harmonics. For generators, do you guys how many have emergency generators on the system? So if you have emergency generators hate harmonics. One, you can cause you to have to oversize them, but the other is, you see how fuzzy that line looks? If you go through the middle there, that's a 0 point, and when a generator, what it's doing is looking for that zero crossing. And if it can't find it, it starts what we call hunting. I think, Joe, you mentioned the term hunting as well, right? So it keeps looking, it can't find it, and then eventually it trips. And then the drive's not going to operate. You can also get surges. So ideally, that waveform, you want to keep it as smooth as possible. You want to have it really smooth. So from the drive standpoint, we do the standard 6-pulse. Lower horsepowers, maybe up to 50. 6-pulse, pretty typical way to go. We get up to higher horsepowers. We like to go with what we call our ULH drive. It's an active front-end drive. That's a more common term. We're not the only manufacturer of that type of drive. But what we do is we actually use those IGBTs on the front, and we control the switching more at that point. And so at that point, we're not even generating harmonics. We put a little additional filtering up on the front of the drive, and so now that's the kind of waveform that you're seeing going back out to the front side. So it's a very clean waveform. I got that zero crossing. That issue goes away from that standpoint. It's just very clean, so everything can be sized, more what should be sized for, and in much better operation.
Cost savings on generators, right? You put in a new generator, you want to oversize it.
Yep. Yeah, we've actually done some comparisons on that, where what you do is you're looking at it saying, okay, I use a 6-pulse drive and size it based on the generator I need, and then the generator has to be upsized. I put in the ULH or the low harmonic drive and do the same analysis. I generally can go with a lower sized generator, and so now I have the cost savings in that generator alone pay for the little bit additional for the drives. But there's also additional advantages for that type of being able to control that DC bus with those front end IGBTs. We can actually do voltage boost. So if you have a situation where you have, your supply is way over there, you got a long distance going over to where your drive is, you can have a voltage drop situation. So the actual voltage that you're seeing, say, at the drive, maybe it's 426 volts versus 460. And that's what's going out, would normally be going out to the motor. So now you got a motor that's not getting enough voltage, so it's going to have to run at higher amps to actually give you and handle the load that you need. The ULH type of drive can actually boost that voltage. So you can boost it back up, and then it just boosts it up, and now the motor's operating at the right voltage that it needs to. Same situation could be if you have a long distance between the drive and the motor. You have the same voltage drop type of situation, so the voltage boost can be set on that, and it can boost it up and give you the proper voltage out that motor. So good conditions. You run into this a lot because a lot of the pumping stations are, the remote sites, right, come in handy. And the last one, power factor. Real talk, I'll just give you a quick on that. Power factor is an indicator from your energy standpoint how much useful power you're doing. So it's going to be a unity power factor is the ideal. And with that ULH drive, I can just set it to operate at unity. So I'm always getting the most efficient energy operating from the standpoint. The other is that on generators have a narrow power factor range. They really hate leading power factors. And we set this at unity, generators are always going to be able to operate with that. So, all right, so back onto the mechanical side from the water hammer standpoint. When you go to start your load, a lot of times if you're starting across the line, you can get that big surge, so that you get that water hammer. The water hammer is just, the term comes from the shock, and then the pounding side. So that's why they call it the water hammer. We look at these curves here. The far left shows when I go to start, say across the line, just a normal across the line starter, I get that rapid start, so I get the big boost in flow. You could put a soft starter. That's another way to start a motor. Soft starter does a little bit better job, slowing that flow down to push it, but the drive more naturally mimics that. So it gives you that smooth, soft starting capability. From a torque standpoint, the soft starter, since it has a lot of torque, the cross line a lot of torque, the soft starter less torque, and then the drive is very low torque. So there's that less thrust that's going out there that's going to cause you those problems with the water hammer. When we back to our water circle, some of the things that we do that kind of help with that. One is we can do a soft pipe fill, and what we're doing is basically monitoring on pressure, and then we can kind of control the pressure and make sure that pressure doesn't come up too quickly, and that's going to help to reduce from that water hammer standpoint. We can do the monitoring for low flow, high flow, low pressure, high pressure. So that's going to help to make sure that we don't run into a water hammer situation, or we go back to the aging infrastructure. Not sending out something that's going to be too measured or cause breakage. And the last, in the drives, we can actually bring in, say, your level detectors can come directly into the drive. And then what we can do is if you have multiple pumps, so say you have a pump station, you have 3 pumps, maybe you're running 1, maybe you're running 2, we can actually, based on the level, we can, bring those pumps online, and that makes that transition then, from one level to another very smooth with the operation of the drive. And we can just do a lot inherently in the drive. We can switch, make one drive the lead, let the other one be, now rest, and flip them, back and forth and operate those drives. So those are all just inherent, within the drive itself.
Michael, working on that, I've seen before too, where you got a weapon that's building up some sort of like fat oils and greases, and you get some sort of get a consistent level in there, you're getting that build up, and then eventually grease over at the top, and you might have some trouble pumping it down, but adjusting those levels at different times so you're not really
Oh, yeah.
essentially pumping out the grease manually rather than pumping back maybe 10, 15 manually.
Yeah, so in that case, you're using the level just to make sure that that level's going up and down, so it's actually getting, not just sitting there in that one level and building up.
Essentially alternating that.
Yep. So along with that side, then we have some built-in protective functions, features, within the drive itself that can be utilized. Kind of hit up on each of these. If you have submersible pumps, typically what you have to do is you have to give them a quick ramp. The quick ramp's going to let you do the lubrication that the bearings are going to need. You'll have a secondary ramp, and the secondary ramp is going to be there to eliminate turbidity. And then you can go to your normal ramp control. And that's just, like I said, it's standard in the drive from a setup standpoint in there. A lot of people don't realize they have it, and they don't set it up. So it's something that's just available. Cavitation. Cavitation occurs when you have like the rapid changes in the pressure. So the cavitation, you get the development of the air bubbles, and if those air bubbles, if they implode, then they can cause impeller damage, on the units with that. We can actually set the cavitation up, and what we're doing is we're just continually monitoring, and it's a proprietary algorithm in our drive. I believe other drive manufacturers may have it as well. What we're doing is we're continually monitoring that flow. We detect the cavitation, and then we back the drive off. We try to get rid of the cavitation, and if it doesn't, we'll back it off again, try to get rid of the cavitation. If once it's gone, then we'll bring the drive back up to speed, have everything operate. If it detects it again, it would just continually back it down. If it doesn't go away, it'll eventually shut the drive off. Because at the end of the day, we're trying to protect that pumping asset that you have with that. And that's again. And that's a setting that can be turned on and off. It's inherent in the drive. And another one that we have on there is the ability from the, do you guys have any issues with like, rags and all that, from the pumping application? I see some smiles and, some nods with that. There's a feature in the drive, sometimes called pump cleaning, sometimes they call it deragging, different terms that you'll see used with that. For that feature, what we do is we have the ability to basically kind of give quick start stops, forward reverses, to the, for the drive. So the impeller is just going to, shake. We look to eliminate the debris on that. If your pump can only go forward, you just do them from a forward basis. The nice thing with this, you can set it up to run periodically. It could be set up to be run based on detection, and then actually give you an indication of when that's happened, because that could tell you that, hey, I got some other problems that are building up. Or you could just do it as a normal preventative maintenance, and from time to time go in, and run that just to keep things clean with that. It's actually looking at your, I think it's looking at a high amps, the overload conditions. It's actually looking at under or over, conditions and stuff that it's looking at. And I'm gonna pass that one. That one's basically in the drive. We have an algorithm that if your flow switch failed, it could become. You could set this up to be a backup to the flow switch. It's if you do it with a switch, it's pretty accurate. If you're just doing it based on power, it's not real accurate. But again, if it's for backup, it's going to be it's going to be better than having nothing and having to have your system shut down. So it's a feature that can be set up in that unit. Get you through the night's a good one. The other one, probably more relevant, is a dry pump protection. We have the ability that you can set it up. You could do it from a monitoring standpoint, but you could also actually input a curve, into the drive itself, and it considers that to be a no-load curve. And if it goes below that no-load curve, well, you can have it set to either fault or to give you a warning, and give you an indication of that. So a nice feature that's built into the drive. Aging infrastructure. I'm going to pop through these for you a little bit. We talked about the different things for like your, we can, monitor for high pressure, low pressure, the flow conditions, the water hammer, base to control those, right? I mean, if you got, older, piping and stuff in the system, you send a big surges down it, right? That's could cause a problem. Now you got more leakage, you got more breakage, right? Those are ones that are, inherent and built in. We talked about those. You can replace, some of the older drive styles like the 6-pulse with the harmonics, if the harmonics are becoming more and more of an issue. What I wanted to hit upon is more of the environmental aspects. All the drives are temperature, they're temperature rated. So it has a temperature rating that you need to maintain for that drive. So one of the things we always want to make sure is that you have it in an environment that's going to kind of stay within its range. So, it's hot or cold, we just want to stay with, with the range. The other is the enclosure type. So like, I'll stand over the flag, but, so like this drive is a NEMA 1, we call it a NEMA 1 drive. The NEMA 1 drive, you could mount this, on a wall, right? And the temperature that it's worried about is the ambient air that's around that drive. And if you stay within that, parameters, it's gonna, operate just fine. You take that drive and put it inside of a box. What air are you concerned about now? Drew? The air in the box, right? So now you've taken that drive, you've enclosed it into a box, and you've put a bunch of other stuff around it, right? So you've reduced the airflow that's in there, and you've enclosed the heat. So you have to take that in consideration. So you got to be cautious sometimes when you're doing retrofits, because you think, I just throw this in there. You still got to kind of look and make sure that I'm going to have, enough airflow and air circulation, within that. The other is that the classification NEMA 1, NEMA 12. NEMA 1's your lowest one. NEMA 12 gives you some protection against dust, a little bit of moisture and all of that. So in general, we're kind of going NEMA 12, for the most part when we're putting the drives, into somewhere inside applications. You could go outdoors with them, a NEMA 3R. And Drew, you mentioned our NEMA 4X. We have drive goes up to 30 horsepower. It's a NEMA 4X drive, and you can put it with or without a disconnect. So you could actually mount that outdoors, and stuff for, from that environment. But another issue that you run into are gases. The gases stuff we run into in the industry, and protection of the drives with those. So nice. And one thing you want to look at on the drives is to make sure that the drives are coming with conformal coating on the boards. What it's going to do is, give you more longevity and stuff, on the drives themselves with that. So always kind of look for that, on the drive standpoint. I see this. I got to stay out of the range to stay within here. So installation practices, we'll kind of cover a couple different ones that you can run into. I'm going to pop through each of these to get you up to it. So one of the things with the drive, and I'm going to go right up to here to give it to you. That drive on the output, remember we said it had those pulses that are going out there? And that pulse is then generated, there's a voltage, and there's a term we call common mode voltage. What it can lead to is currents that can kind of flow back, into the system. I see it nodding going on there. Is there a reason? Or I didn't know if you've run into problems. So that's what happens though is those currents they want to get back to the drive. And so the proper way to correct against that is you help them get back to the drive. And so one of the things you want to be looking at is your installation from the wiring standpoint. So one of them you're running a lot of times is rather than having a continuous ground, say from the motor to the drive, it'll be broken up. Maybe you'll land in a panel and you'll have a separate grounding location in the panel and then the other going over to the drive, and then that's a break. And that results in the noise, and the noise doesn't get back, or the currents don't get directly back to the drive. So one of the things we would like to see is that continuous ground in there. Metallic conduit or shielding are others that are good installation practices, to put in from that standpoint. Cable type. You guys know what kind of cables you guys typically are using running the motors at all? THHN was a big one a long time back. That's cheap cable. So in general, for practices, we don't recommend THHN. Couple reasons. It's got a thinner insulation. So when you're pulling it through the conduit, it's subject to being, to tears. Those tears then, what can happen is then you get like, you can have a ground short, with that and stuff. So then now you get problems coming back from a ground fault, situation with that. They also aren't good for moisture. So they can actually absorb the moisture, and that causes ground noise issues as well with that. So what you want to make sure and do is, we like to see like a XHHW2 or a VFD cable if you got the money and for that as well, because they have thick insulation, and they're also moisture resistant, which works both for those. The XHW2, you'd want to put that in metallic conduit. That's going to help. Again, we want to bring everything back to the drive, right? And then the VFD cable, it's got the shielding, so you may not have to do that. That's a code, thing more from the conduit standpoint with that. This was the one that Drew was talking about from the motor standpoint. On that output of that drive, what's going to happen is I'm doing those pulses. I can get a rapid shoot up in the voltage, and it's going to come very quickly. Depending on the distance between the drive and the motor, I can actually have what we call a doubling effect. So rather than seeing just 600 volts, I could see 1,300 volts that's actually being hit out to the motor. The issue is that a normal motor is only rated, say, for 1,000 volts from that insulation standpoint. So if you have an older installation and that motor is only good for 1,000 volts, you put a new drive into that installation, there's the potential that it could be seeing 1,300 volts. If you're putting in new installations, we always recommend the motor should be per NEMA MG1 Part 31. That covers variable frequency drive use, for the motor. And what it does is it gives that a higher insulation rating, and it can handle the quickness of that rising up to there. So number one, if you're doing new installations, make sure it's a new motor. The new motor meets the proper specifications for that. If you have installations where you're just looking at or you don't retrofit, you don't know, then we look at some kind of output filtering on the drive. It could be a reactor, a DVD filter, a sine filter. If you get into that type of situation, reach out to Drew. Reach out to me, but you can reach out to Drew, and we can help identify what would be the right device to put on the output of that drive, just to make sure you have a good installation with that. Couple things, features built into the drive from that electrical standpoint. You always want to know if you've got a motor disconnect, out there at your application. You need to know if that disconnect is open or closed. Typically, it's done, by hard wiring, out between the drive, and then out to that disconnect. You don't have to hardwire. We actually have built into the drive where it can actually detect if that disconnect is open or closed. So it's kind of a cost savings if you don't want to have to run that distance out there. If you have the disconnect out there, you have these drives, and you're not running something out there, it's a good feature to enable in the drive because it's right in there. Another is motor preheat. We have built into the drive where what we can do is we can actually send a pulse out to the drive. It goes through all the windings, in the motor, and that can actually keep the motor heat when you get into the cold, prevent the condensation buildup, and that's standard, within the drive itself. So it's a nice feature that you really can consider turning on, especially if you don't have like a hard wire type heater or high control going out there. And this gets into from the drive standpoint. How many of you guys have PLCs in the system as well, and PID controllers in the system as well, right? So Part of this kind of gets into, there's some capability that you can do directly in the drive that you maybe don't need to necessarily do in a PLC. So if you just have like a pump station and you're putting a PLC in there and it's doing nothing more than PID control, something like that, you can bring, the signals directly back into the drive, use the PID write integral that's in the drive itself. So that's one, something to consider, that's available with the drives. We talked about that level control and bringing your level flow devices, directly into the drive, and then doing that. Sometimes you call it pump cascading, where you alternate between the drives that you're going to operate. That's something you can do. It's a lot of times done in a PLC, but it can be done directly in the drive. And go past this. If you are using a PLC, one thing you want to make sure that it's set up from your SI, your systems integrators, and all. I think everybody said they pretty much are using systems integrators, right? That they have some means of detecting for comm loss, and then what are they doing upon that comm loss? So what we do is, we have a way you set up the comm loss. The drive can detect, oh, I have lost communications with the PLC, and then you tell the drive what to do. So you may say, hey, I need you to run at this speed. You may say, I just need you to stop. Maybe you have some level flow and switches that are coming in, and then they're taking over and doing the control. But you want to make sure that they have that capability set up, within the drive. It's built into the drive to do it, to detect that comm loss. So we just want to make sure it's set up properly. And now the operator panel. You kind of went through this for the most part, but one thing we like with this drive is the ease of setup. With that, you don't have to go up to our drive with a computer to set it up and and make it operate it. You can do everything really just through the drive. Simple setup. 7 commands, I think, you can get a drive up and running if you're staying within the standard features that are built into the drive. We do have the capability on the drive, for you to go into a hand mode. So you have your hand, you're off. Auto would be if you're doing your PLC control. If you wanted to use this only, say, for you don't want anybody using the hand on the keypad, you can disable it. But you want them to be able to do speed control, you can keep the speed control. So there's a lot of flexibility on how you actually use that operator panel out, out in the field. The displays. You can set your displays up more or less as how you want to see them. Real common, we may show, speed, what's the speed, different 3 levels grow, but maybe you want to have something that looks more like an analog meter, and that's how you want to display. Or maybe you want to show energy savings, or energy usage. You have the capability of doing the different displays and take a look to how you want to do those. The VFD is going to let you go in through its menu quickly to see any monitoring for diagnostics. So if you've had a fault condition, it's going to help guide you through what that condition may be, and then maybe what a procedure would be to get the drive back up and running. And actually, that kind of completes my part for this, because we go back with the circle. The circle are features that are inherent in the drive, things that if you're not using them and they can be a benefit to you, remember to turn them on and activate them, right? But when you're looking to select the drives, it's good to reach out to us because we can help you guys pick the drive that might be the right for the application with that.
Just real quick on that, if drive going to service a new drive, it's always nice to have one of your folks out there, operators, electricians, with the integrator, starting just to hammer on some of these features. Right? The specs and the engineers don't often call for a lot of these features, right? It's more customizable stuff. It's maybe plant specific. So sitting with whoever's out there, starting to going through some of those features maybe that you want. The auto restarts, things of that nature that is kind of specific to the processing.
Yep.
We're very receptive helping folks out, getting courses, things like that, to try to train folks that are interested in learning about it. Some integrators handle it all, some guys do some of it themselves. So.
Yep. And as you said, we have formal courses for training. Those are done in person in New Berlin. but we also do more that can be done remote, meaning we ship the equipment out, and there you attend the course virtually. As Drew and I just talked as well, though, it maybe a subset of the whole group here, but I've got one of these demos. Drew has one of these demos. We have access to additional demos. So if people really want to say, I just want to spend like, a few hours, 4 hours, just kind of, playing on the ground, go through the basic setup and things like that, we could easily set something up, for you guys, for the group and stuff, if people want that kind of, additional hands-on and stuff with the drives. Any questions?
So we have a process right now that is run with a VFD, but the process is down and the VFD is outside. Right now we have that VFD de-energized, but I'm wondering if we should have that VFD energized for heat inside of it. Is there harm in having a VFD off outside of it?
Well, no, they'd probably be okay with that. I mean, if it's going to be off for a long time, and I mean like, okay, that's probably okay then. What Drew was talking about is, I'm going to comment to this first, and then we'll kind of think on that. Sometimes people they'll get drives as spares, and then they'll put the drives on the shelf, right? And that's fine. That's good because it's an easy, replacement at that point. But the problem is if they sit on the shelf for too long, like 1, 2, 3 years, the capacitors in there begin to discharge, and they have to be what we call reformed. I mean, it's a simple process. You're just getting a trickle voltage, to devices. But you would want to do that before you went and installed it, because what will happen is the drive will just fail, in those. On yours, what I'd have to look at is the drives do have a storage limit. So what we'll do is check the storage limit versus the operational limit. And if you're in good within the storage limit, you should be okay. My only concern is condensation buildup and stuff, going on there. And that would be the advantage to having the heat out there to prevent condensation buildup, say up in that panel. And then when you go to fire it up, you could have a lot of condensation that could be sitting in that panel, which would be bad.
So just having the drive powered on but not actually operating, would that provide enough heat?
I'd have to check that. So we're done. We'll exchange and find that. But it's still, it doesn't matter. That's a question I can take, back to our people and, and stuff with that. Do you have a space heater in that panel?
No, there's no room for it.
And there's no room for it.
It's literally mounted on unistrut with an enclosure outside.
Okay.
The conduit runs up to the enclosure.
Got it. Okay. I'll figure a way to generically ask that question and get an answer back for you on that. Because basically you're looking at if it's sitting in idle, is it going to generate enough heat to prevent condensation, buildup in there? And I want to say yes, but I want to say yes after I've gotten an answer for you on that officially. So, yep, that's a good question. Everybody experts now? Expert enough to do what you need to do, right? And that's a big key. But if you guys have questions, want some additional things, we're free to. We touched on a lot of things, but touched on them quickly. That harmonics thing is a full session, in itself, and stuff with that. And we're trying to, graze across topics. So, right? Thank you very much. Thank you, sir. You need this.
That concludes today's session. Thank you very much.